This is section 4.2, part 1. Today we're talking about the trig functions and how they relate to the unit circle. So we're going to go ahead and get started with our first objective, and that's going to be to use the circle to define these trig functions. Now, one thing you're going to notice is that we have 6 trig functions here rather than 3. Now, sine, cosine, and tangent are those basic trig functions you learned in geometry. We're adding in 3 more: secant, cosecant, and cotangent. Now, those 3 functions are going to be the reciprocals of sine, cosine, and tangent. Before we go ahead and get started in defining these, I want to take a look just at a unit circle for a minute. What I'm going to do on this unit circle is I'm just going to draw in an angle. And it doesn't matter which one I draw in. We're just going to draw an angle there, and we're going to call it theta. Now, theta relates to the point on the unit circle where this angle ends, where the arc ends that makes this angle. We're going to see how we can use this point on the unit circle where the angle ends to help us define these trig functions. Let's go ahead and drop down an altitude and make a right triangle. Now, in terms of x's and y's, we know that the horizontal side of this right triangle is the x and the vertical side is the y. The other thing we know is that the radius of this circle is 1 because it's a unit circle. And remember, in a unit circle, the radius is 1. So right now, if I just draw this to the side here, I'm dealing with this angle here, theta, x, y, and a radius of 1. And that gives me the point on the unit circle. So that point could be called x, y. Let's use this triangle and our knowledge of right triangle trig, so katoa, to try to see if we can define these trig functions now. Starting with sine, remember sine is the opposite side over the hypotenuse, and if we look at this triangle, the opposite side is y and the hypotenuse is 1. So that tells me that the sine of theta is equal to the y value where that arc ends. Cosine is adjacent over hypotenuse, so it looks like cosine is the x value. So this point x, y, you could also think of it as cosine, sine. Now, oftentimes we want to think of it the other way. One of the most common mistakes I see is to think that sine is the x value. I think it's because sine just naturally in our head comes first, but cosine should be the x value, so cosine, you have to remember cosine as x. Since tangent is opposite over adjacent, tangent is going to be defined as y divided by x. And that defines our first 3. Now, in terms of secant, cosecant, and cotangent, these are the reciprocal functions. Now, many times we'd want to think that secant is the reciprocal of sine because they both begin with s. But secant is actually the reciprocal of cosine. So we want to define secant as 1 over x. That makes cosecant 1 over y, and cotangent is the reciprocal of tangent, so it's defined as x over y. So just remember, sine goes with cosecant, cosine goes with secant. It's opposite of what you would think. These are going to become very important to us, and you want to make sure that you have these memorized. You're going to need to know these and to be able to recall them very quickly. Now let's take a look at an example and see how we can use them. So here's our example. T is going to be a real number. Now notice T is going to be an arc length here. And P, this point, negative 1/2 root 3 over 2, is the point on the unit circle where that arc ends. We want to find the values of our 6 trig functions according to that. Of our 6 trig functions, we want to find the values of them. So let's go ahead and start. We'll start with sine, cosine, and tangent, the first 3. Now remember, we said sine is the y value of our point. So that means sine is going to be root 3 over 2. cosine is the x value, so we get negative 1/2. And tangent, we said, is y over x. So we would get root 3 over 2 over negative 1/2. Now you can see here that we're going to have to be dividing fractions, so we're going to use some shortcuts here. The first I'm going to use is the shortcut we learned when we looked at that fraction worksheet, where when we have dividing fractions with the same denominator, the denominators are going to cancel out. So it looks like this is going to just end up equaling negative the square root of 3, or negative the square root of 3 over 1. And so there are our first three: sine, cosine, and tangent. Now to find the others, we're going to have to take the reciprocal of those. And I'm going to rewrite these in a different order than they were on the last slide. I'm going to put cosecant first next to sine, since it's its reciprocal. We'll put secant next, and then we'll put cotan down here at the bottom. And to find each of these, we're just going to do that 1 over all of those, the reciprocals. Basically, we're just going to take our answers from before and flip them over. So if I take sine and I take its reciprocal, I just flip it over and I get 2 over the square root of 3. But remember, we have to rationalize that denominator, so I'm going to multiply the top and the bottom by root 3 over root 3. And I get 2 root 3 over 3 as that final answer. For secant, I just have to take the reciprocal of cosine, and when I flip that over, I get negative 2. And finally, when I flip over negative the square root of 3 for cotangent, I'm going to get negative 1 over the square root of 3. But again, we have to rationalize, so we multiply by root 3 over root 3. So we're going to end up with negative root 3 divided by 3 when I rationalize the denominator. So there are the values of our 6 trig functions at that point, negative 1/2 root 3 over 2. And you can see that we found sine, cosine, and tangent using the x's and the y's. And then to find their reciprocals, we just took all of those and flipped those fractions over. Here's a multiple choice question for you to try right now. I want you to find the cotangent of 5 pi over 6. And I drew a unit circle here, and I'll help you. 5 pi over 6, remember, is going to be right here. So you're going to use this point, negative root 3 over 2 1/2, to find the cotangent of 5 pi over 6. And once you do that, you'll put that answer into your Google form, and then you can go on to the next slide. The last thing we're going to talk about today, we're skipping ahead a little bit to objective 3. We'll go back to objective 2 tomorrow. But we want to still find the exact values of those trig functions, the same process as earlier, only now we want to do it at pi over 4. So now we're given a specific point right here, pi over 4, and this is the one we want to use. So here's the angle we're talking about right there. Now we need to know what this point is. I'm going to tell you today that this point is root 2 over 2, root 2 over 2. Now, before we find the values of those trig functions, let's take a look at why that's the case. I'm going to draw just that angle again here, and I'm going to draw it and I'm going to drop it down into a right triangle already. Now remember, this was a 45-degree angle, and so it's going to be a 45, 45, 90 right triangle with a hypotenuse of 1. Now hopefully you remember from the past that both the sides of a 45, 45 isosceles right triangle are the same, so we'll just call them A and A. Now, if I do the Pythagorean theorem here, I see that A squared plus A squared equals 1. So 2A squareds equal 1. And when I divide by 2, I see that A squared equals 1/2. Now, if I'm solving for A and I take the square root of both sides, I can see that A equals the square root of 1/2, which is the same as the square root of 1 over the square root of 2. continuing on, the square root of 1 is 1 over the square root of 2. And if I rationalize that denominator, I can see I get root 2 over 2 is my value for a. So that's why both x and y in the 45-45 right triangle are both a and a. So going back, that's how we got the sides to be root 2 over 2 and root 2 over 2, because at pi over 4, we're going to have that isosceles right triangle, and then those side lengths are going to be the same. And since it's a unit circle, that's going to be their value. Now that you have those, I'm going to let you go ahead. I'll start you off with sine, but I want you to go ahead and find the rest. Sine, cosine, cotangent, and then cosecant, secant, and cotangent. And I'm sorry, we should put tangent down here. So just to start you off, remember sine is the y value, cosine is our x value, tangent is y over x. We're going to have root 2 over root 2 over root 2 over root 2. And you'll see these are all the same thing, so this quickly equals 1. I want you to find the other 3. And let's change this to putting in cotan of pi over 4 as your free response question. And then this is where we'll end the video for today.